Within the Milky Way, the Earth resides on the inner edge of a spiral arm. But this isn't our permanent address. When most dinosaurs went extinct, our solar system was in a different arm than it is today. The Milky Way never stops changing. Even its structure continues to evolve. To see why, let's start at our galaxy's very beginning, 13 billion years ago. Propelled by supernovae and the general chaos of the early universe, the gas and dust particles that eventually became our Milky Way were whizzing around in every direction. Each particle had a certain angular momentum, the magnitude and direction of its rotation around the emerging galaxy's center. Just as the new galaxy's total mass was the sum of the individual particles' masses, the galaxy also had an angular momentum that was the sum of the particles' angular momenta. So, despite the wild motion of its parts, the galaxy as a whole was rotating about an axis. Meanwhile, the gas and dust particles frequently collided, losing some energy to heat. Because they slowed down, gravity was able to pull them closer to the galactic center. So why did the Milky Way, like most galaxies, become flat and not spherical like stars and planets? The answer lies in its angular momentum. The laws of physics dictate that in the absence of external forces, the total angular momentum of an object or system has to stay the same over time. In a star or planet, the spinning material is so dense that the outward pressure partners with gravity to create a mostly spherical shape. But emerging galaxies tend to have low densities and high angular momenta, meaning that the spinning motion is a more significant factor than the outward pressure. Indeed, if a galaxy has a lower angular momentum, an egg shape can form. In galaxies like the Milky Way, particles, instead of falling directly towards the center, tended to fall parallel to the axis of rotation, as to keep the larger total angular momentum constant. Over billions of years, the cloud of particles gradually fell, sped up in their orbits, and created a spinning disk. Now what about the arms? Spiral arms like the one Earth is in are regions where stars and gas are packed more tightly together. But the arms aren't static structures. They're caused by zones of compression that travel through the galaxy as waves. Just as a whirlpool has multiple peaks and troughs, a density wave in a galaxy has multiple regions of high density, the bright spirals, separated by regions of lower density. And as the wave travels, different stars are constantly entering and leaving the spirals. Density waves can form in several ways. For some galaxies, a nearby companion galaxy stirs the pot. Its gravitational pull breaks the disk's symmetry, generating a wave that could last for 1 billion years. For other galaxies, the presence of a small clump of tightly packed stars and gas within the galaxy can have a ripple effect, spontaneously giving rise to a wave. This is thought to be the cause of the Milky Way's spirals. In both scenarios, the galaxy's overall rotation bends the dense region into spirals, which rotate around the galaxy's center. Our solar system is orbiting the galactic center faster than the spiral arms. We'll be moving deeper into our current arm for millions of years before eventually putting it in our rearview mirror. And recent observations have added another wrinkle to the picture. Rather than just one density wave, a typical spiral galaxy likely has 2 or more waves that overlap with each other and travel at different speeds. The result would be spiral arms that last for tens or hundreds of millions of years before breaking apart and reforming. This may be happening in the Milky Way, meaning that when the Earth formed 4.5 billion years ago, the spirals themselves may have looked entirely different than they do today. In any case, our spirals won't last forever. About 5 billion years from now, the Milky Way will start to merge with the Andromeda Galaxy, throwing off the balance of angular momentum and creating an egg shape, the birth of a new era in our galaxy's history.